Welcome back, everybody. This is the first day of the second unit. So we look at consumer choice, and we'll begin by exploring a concept known as elasticity. And the goal will be to try and understand what price elasticity is, how to interpret price elasticity, and then utilize that information to determine whether goods are elastic or inelastic based on the change in total revenue that occurs when the price of a good changes. So we start with a concept that people are sort of familiar with, and that is rubber bands. And if I took the rubber band on the right and I tried to stretch it out, it would take very little effort. I could just put very little effort in and it would stretch very, 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 very far because rubber bands tend to be elastic in nature. The silicone band on the left, however, if I were to try and put a little bit of effort into stretching it, it wouldn't go very far. Silicone bands don't tend to be elastic. They tend to be inelastic. There's not a lot of spring to them. It would take a lot of effort on my part to get it to change shape and begin to stretch, unlike the rubber band, which stretches very easily. And it's the same concept in economics as we talk about elasticity. When it comes to elasticity of demand, what we're saying is, or looking at, what happens to the quantity of demanded of a good when the price changes? If the price changes and there is a relatively large change in the quantity demanded as a percentage change, then we say it's elastic. So if I change the price by 2% and it leads to a 10% change in quantity demanded, a little bit of force leads to a huge change, then it's elastic in nature. And if the change in quantity demanded is less on a proportional basis to the change in price, we'd say it's inelastic. So if I change the price by 2% and I only get a 1% change in quantity demanded, we would say it's not very responsive to a change in price, and that would be inelastic in nature. We measure elasticity by the formula percent change in quantity demanded divided by the percent change in price. And that number will change as we move up and down the demand curve. The demand curve itself does not maintain a consistent elasticity. It actually changes as we go either up or down the curve. If we have a vertical demand curve, we say that it is perfectly inelastic. That is, that the quantity of demanded does not change when the price changes. I can increase the price by 100%, and the quantity demanded changes by 0%. There is no change at all. And one way to remember this is that vertical demand curve sort of looks like the letter I for inelastic. Perfectly elastic, on the other hand, is when a demand curve is horizontal. A change in the price leads to an infinitely large change in quantity demanded. Essentially, if you charge me 1 penny more than the price, I will buy 0 products. I will want none of them. And if you charge me 1 penny less, then I would essentially want an infinite amount of the good. So perfectly elastic is horizontal. The way to think about it is that this horizontal line sort of looks like the beginnings of a capital letter E, as you can see here. So elastic demand curves are horizontal in nature. And we find that all elasticities sort of fall between those two bounds. So your demand curve will either be perfectly inelastic vertical or perfectly elastic horizontal or somewhere in between. There is one other sort of special elastic, and that is unit elastic. At the unit elastic portion of the demand curve is where elasticity is equal to 1. That is, the change in price and the change in quantity demanded are equal in percentage terms. So that unit elastic portion is sort of a special spot on the demand curve. So how do we use elasticity? What's the purpose of it? Well, one of the things it can do is help us identify or predict what will happen to the market if we were to raise the price or lower the price. And as a supplier, it's good to know what the elasticity of demand is for your customers, because you can then predict what will happen to your total revenue. You can predict what will happen to the amount of money you collect if you were to change the price of your good. And the question of whether to increase the price or decrease the price in order to make more money sort of depends upon the elasticity of demand. So elasticity is connected to total revenue because it can be predicted what will happen to the amount of money coming in with a change in price. So when it comes to vocabulary, total revenue is equal to the price of the good times the number of goods sold, or price times quantity. That tells us the total amount of money coming in. And the change in total revenue will be dependent upon which of two effects is greatest. You have what's known as the price effect and the quantity effect. With the price effect, a change in the price leads to all goods being either more or less expensive. So if I raise the price, it means that every single good I was selling at a previous price, I'm now selling at a higher price, which would cause total revenue to rise. The quantity effect, however, says that when we change the price, that affects the quantity demanded. So if I raise the price, then that means that there will be fewer goods demanded. The quantity demanded will shrink. So that leads to a loss in revenue. So price effect, I'm selling products for more than before. That's adding to revenue. Quantity effect, I'm selling fewer goods than before. That's taking away from revenue. And the question really is, which of those two effects overwhelms the other? The answer to that question determines whether your total revenue will rise or fall if you were to change the price. So, for example, we could have a price of 90 cents. And if we have a price of 90 cents, total revenue is these areas B and A. If I raise the price to $1.10, then I am losing out on sales here, 900 to 1100. I'm not selling that many goods anymore. I'm losing 200 units sold. And I'm losing those 200 units that I was selling at 90 cents. So area A is sort of the lost revenue as a result of the quantity effect. But I am selling some products that I was selling at 90 cents now for $1.10. That's raising revenue. So the 900 items that I'm still going to sell, I'm no longer selling for 90 cents. I'm now selling them for $1.10. So that area C is showing the increase in revenue as a result of the price effect. So whichever one of these areas is bigger will determine whether revenue is going up or down. So let's look at how we might use this information. Let's assume that demand is elastic in nature. Then we could write down this formula, percent change in quantity demanded over percent change in price. And I know it's elastic, which means the quantity demanded, the change in quantity demanded will be greater than the change in price. So we could put in numbers like 10% in quantity demanded and 5% in price. And if I said that we drop the price by 5%, that means that the quantity demanded should go up by 10% as a result of the law of demand. Now, this comes out to a negative coefficient, but for our purposes in economics, we're going to report this out as the absolute value. But we do care about the sign in so much as I can determine what's going to happen to total revenue, because what I will do is look at the two numbers, figure out which number is biggest, and then look for its sign. In this case, 10 is bigger than 5, and 10 is positive. So we're adding 10% to revenue when we take away the price by 5%. So I'm reducing the price by 5%, that's negative. I'm adding 10% quantity demanded, so the net on that is a plus 5% change in total revenue. So this tells me that when demand is elastic and I drop the price, then I will see an increase in total revenue. And then we could do another example, and you're going to give it a shot here, where we're going to assume that revenue decreased with a decrease in price. And the question is, what is the elasticity of demand? Is it elastic or inelastic? So I'll give you a second to try and see if you can work through that problem. Press pause in just a moment. Work through the problem. When you think you've got it figured out, press play and see how you did. So if we're saying that revenue decreased with a decrease in price, that tells me that the price is negative. So that has to be the bigger of the two numbers. So change in price, I just threw in some sample numbers, minus 10%. The quantity demanded must be a positive number, and it's got to be smaller than the drop in price. So we say 5%. So we see that this is 1/2. So 1/2 is inelastic. So I would say that when revenue decreases with a decrease in price, then we are dealing with an inelastic portion of the demand curve. Now, why does elasticity change? Elasticity changes along the demand curve because we're measuring changes, percent changes, not total changes. So a lot of students say, well, isn't it slope? Isn't elasticity equal to slope? It's not equal to slope because slope is just measuring rise over run. Elasticity is looking at the percent change. And so if we go from 1 to 2, if the price goes from 1 to 2, we're talking about a 100% increase in price. When it goes from 99 to 100, then it's a 1% increase. So even though they're in both cases we're going, the price is rising by $1, the percent change is significantly different. And so you will find that elasticity is different along the demand curve. The upper portion of the demand curve is always elastic. There will be a point in which we have unit elastic, and then the rest of it, the bottom portion of the demand curve is inelastic. And one mnemonic to remember this is eat up idiots. E for elastic, U for unit elastic, I for inelastic. And this will become an issue when we get to monopolies as we look at it, because we're going to be worried about changes in total revenue, which is called marginal revenue. So, but for right now, just important to keep in mind that the relative elasticity of the demand curve will change as we move down it. I mean, overall, the shape will be relatively elastic or inelastic, but even on a very inelastic demand curve that's almost vertical, there will be a portion that is elastic in nature and a portion that is inelastic in nature. So there will always be a portion where if you drop the price, you'll see revenues increasing, and another portion where if you drop the price, you'll see revenues decreasing. And so we could sort of graph it out, as you can see in the table, that the elastic portion is in the upper half of the demand curve. As we drop the price, the drop in price is less than the increase in quantity demanded because people are elastic. They respond with more change than the change in price, and we would see total revenues rising until we hit unit elastic where it is topped out, where we're no longer adding or subtracting to total revenue. As we enter into the inelastic portion, then we begin to see total revenue drop because people do not respond as much as a percentage basis to a change in price, and therefore we start losing revenue as we drop the price. So here again, here's some practice. We can work through one together. Quantity demanded decreases by 7% while prices rise by 10%. So what will happen to total revenue? I would write out the formula for percent change quantity demanded or percent change in price, that elasticity formula. I would plug in the numbers. I would say price went up by 10, quantity demanded went down by 7. I look for the biggest of the two numbers. In this case, that number is 10. That's a positive coefficient. So that tells me that total revenue will increase with a decrease in price, with an increase in price. When elasticity is inelastic and you raise the price, you will increase total revenue. Quantity demanded increases by 15% while prices fall by 5%. What will happen to revenue? Take a shot at it, press pause, figure it out, press play again, see if you get it right. Again, we'll start by writing out the formula for elasticity, and we will say prices fall by 5, quantity demanded increases by 15. I'm gaining 15% because of the quantity effect, losing 5% because of the price effect. I look for which number is bigger. 15 is bigger than 5. The sign for 15 is positive. That tells me that the total revenue will increase. Because this number is greater than 1, that tells me that it is elastic in nature. If we are in the elastic portion of the demand curve and we drop the price, then we will see an increase in total revenue. Another one for you to try. Again, give it a shot, press pause. In this question, we say quantity demanded decreases by 14% while prices rise by 3. We start with the formula. Always start with the formula. Just write it down. We see that price went up by 3. Quantity demanded went down by 14. 14 is bigger than 3, so I care about that sign. It's negative. That tells me the total revenue went down. This number is greater than 1, so it indicates that the demand is elastic in nature. When we're in the elastic portion of the demand curve and we raise the price, then we will see a drop in total revenue. And finally, we've got quantity demanded increases by 10%, prices fall by 20%. Hopefully you're getting good at this. Plug the numbers in. 20 is bigger than 10. 20 is negative. Total revenue drops. When total revenue drops with a drop in price, demand must be inelastic in nature. There are real life examples in the Washington, D.C. area. We have the Metro subway, and they were trying to decide what to do with prices. And the Washington Post reported that if Metro decided to decrease its fares, it could see an increase in ridership. And if the prices for the fares was just right, the combination of a decrease in fares and an increase in ridership would result in an overall increase in Metro revenue. So looking at that, we can say that this seems to be an example of where the demand, the elasticity of demand, would be elastic in nature. Now, how elastic demand is depends on things like substitutability. If you can substitute one good for the next, you're going to be very elastic to the price. You raise the price on one good, and I can go switch to something that's just the same. I will be happy to do that. And you'll see quantity demanded changing with a much larger than with the change in price. Things like a luxury or a necessity impacts it too. If it's a necessity, I have to have it, then you can raise the price on me and I'm still going to buy it. Whereas a luxury, I could take it or leave it, right? And that's why we see things like some goods tend to be very inelastic, like cigarettes or gasoline, because people just sort of need them. If you're a smoker, it's hard to live without the cigarette, right? So if the price goes up, you just pay it. And with gas, we need to get from place to place. So if the price goes up, you pay it. So there are some other factors here that will impact your relative elasticity over time. Next time, we're going to talk about some other types of elasticity, and I will talk to you then.